In your video last night, Con talked to you a little bit about the idea of adding and subtracting common denominators. I want to point out why we can add common denominators or subtract fractions with common denominators and why it's not possible if they have different denominators. So in this case, I've given you the same thing that you had before. So as you're looking up here, we have this whole fraction chart, and we're going down to 12ths. Granted, sometimes we're not going to have 12ths. We might have 11ths, and you don't see 11ths up here. So this is just for a visual today. I'm going to leave it up here after we're done talking about the intro when I give you your homework so you can refer back to this. I also still have copies for you of the whole sheet that I'm showing you in case it helps you to see this when you're working on your homework today. Okay? So, I'm going to propose, and I want you guys to write these in your homework, or in your notes, sorry. I'm going to add 2/3 plus 4/5. Okay? That's the problem that we're going to deal with first and kind of use this diagram to understand and again review what those different terms in each of those fractions represent. So first of all, 2/3. I have a numerator of 2, denominator of 3. What's the 3 represent? And it may be helpful to kind of review back to the diagram you can see here. What's the 3 telling me? What information? Yes, sir?
How many times the whole is split up?
Okay. How many times the whole is split up? What else is it telling me?
How many sections you need?
Okay, how many sections I need? So what's the total I'm looking for? Good. What's the numerator tell me? Look back in your notes, you guys. We talked about this on Monday. So if you don't know, I never ask you something that I haven't already covered. So what does the numerator tell me? Kirana?
How many?
Good. So the quantity, not how many I need, but the actual quantity I have. All right, so let's take a quick look at comparisons. Here, I have thirds. So 1, 2/3. Okay, so kind of get that in your mind. We're right here at the end talking about 2/3. Then for fifths, I have 1, 2, 3, 4, 4. So we're right here at the end. What do you notice about the sizes? So Johnny brought up the point that the denominator tells me how many sections and the size. What did we figure out as a pattern when I see a denominator change? So here we have a 3 and a 5. What do you notice about the sizes of sections? Crowd goes silent. Levi.
It's smaller than the one above. Like the bigger the denominator gets, the smaller the little fractions are.
Good. So the bigger the denominator, so here I have thirds, fifths. The bigger the denominator, the smaller each section is going to be. So that helps me to kind of come to the final conclusion here is, why can I not add 2/3 and 4/5 as they're written? Johnny.
Because they're 4/5, they don't line up, so they aren't the right fractions. They're equivalent.
Okay. Do I have the same quantity?
No.
No, they don't match up in the first place. Third starts here and the 4/5 stops here. So if I were to add these together, these are color-coded and they have different sizes. Which denominator should I use if I were to add them? Do I use thirds and tell myself I have 6/3? Does that seem accurate?
Yeah.
Because each one of these isn't a third, right? I can't say I have 1/3 just because I have 1/5. Or do I say I have 6/5? Does that seem accurate?
No.
So if I'm talking about a quantity of something, I have to have the same size of it. If I say I have a third, I can say I have 2 because they're identical. So I cannot add these two specific fractions because they're not talking about the same size sections. So the quantities can't be pushed or combined together, not as they're written. So for today, you're going to be dealing with just quantities that are the same, size of sections that are the same. So when we talk about common denominators, we're dealing with the size of sections that are identical. Okay? So, for example, it's not moving. There we go. For example, if I have 2/3 plus 1/3. So we're changing the problem here. Go ahead and put this in your notes. Why would this be an acceptable problem to compare or combine the numerators, the quantity? Johnny?
Because the denominator is the same.
Okay, so I can relate them because they're the same size. So I can say, if I had 1/3 here, as you saw in the video, another third, and another third, then these all match up to give me 3/3. I have 3 of the thirds. So again, thirds is the size of a section. Okay, it's a value. I have 3 of those quantities or values. So I have 1 of them, 2 of them, 3 of them. In the end, though, if we think back of the other value or information that the denominator tells me, it also tells me my total that I'm looking for. So if I have 3/3, what else do I know besides just having 3 parts? I have 3 of the same size parts. Yes, sir?
You have 1 whole.
I've completed that need. I've completed the need of having 3. So having that filled, I have a whole. Okay? So when you're doing your homework tonight, if you get to a problem that you can reduce, if you can simplify, even though you've added or subtracted them correctly, I want you to simplify. Okay? Any questions? Why can I not write 2/3 plus 1/3 equals 3/6? Why does it not equal 3/6? Think about it. Talk to a neighbor. You're going to give me an explanation. And remember, you're changing the denominator this time, whereas before we said 2/3 plus 1/3 equals 3/3. Why is it not 3/6? How would you explain it to a friend, or how would you explain it to a younger grade that is incorrect? Okay, so you're going to talk with your neighbors first, then we'll open it up for discussion up here. Have 3/6 equal to the expression that we just wrote. So again, our expression, okay, our expressions right there. 2/3 plus 1/3. We said it equals 3/3. Why can it not equal 3/6? Zach, what's your explanation? Remember, talk loud.
Because you never add the denominators.
Okay, why do I not add the denominators? If you have a different explanation, hold on to it. But if you feel like you understand why you wouldn't add the denominators, why? What is it about the denominators that tells us we can't add them together? Casey?
It's the actual whole number, but if you were to add them together to make 6, and you had 3 on top of the whatever, you'd have to do the same to the top of the bottom.
Okay. So Casey's explanation is that with having thirds, that tells us how many we need to have to make a whole. If I change the denominator, that changes how many I need to make a whole. So that's changing the size. But if I haven't changed the size for the numerator, do I have equivalent fractions? No. If I change one, I have to change both. So in this case, if I have a 6 here, I've changed the 3 to a 6. What should the numerator be here? 4. If I change the 3 here to a 6, what should my numerator be? 2. So I still should get 4 plus 2, which would give me 6/6, which still equals what? 1. Here, I didn't change the numerators, I only changed the denominators. Here's another way of possibly looking at it. Who has another explanation other than you can't add the denominators together to describe why this statement of 3/6 cannot be the answer? Johnny.
Because if you're dividing, if you're making sections of an object, so if you have 2/3, then you have, let's say, 3 pieces of pie.
Okay.
Then the 2 on top is how many pieces you took away.
All right, so here you're telling me that if you said thirds again, right?
Yeah.
Okay, so if I have 2/3, I had this quantity here, and then if I make it a 6, I've taken this quantity and changed it to this,
Yeah.
which really wasn't its actual size. So let's go back. What does the denominator tell me? What information is the denominator there to tell us? There's 3 things that we've talked about. Yes?
First thing I think is that the denominator says how many sections out of one thing, what the maximum quantity of the thing you have is.
Okay, so the denominator tells me how many sections total I need to make a whole. Okay, what else does it tell me? Think about maybe as a comparison. If I have thirds versus fifths versus tenths, what else does it tell me? Yes?
The size of each piece.
Good. The size of each section. And I know that as the denominator increases in size, so that means the number increases in size, what's happening to the section size? It's getting smaller. So thirds is smaller than halves, and tenths is smaller than thirds. So a 10 is bigger than a 3. The bigger number shows me that it's a smaller section. Okay? If I take that and put it all together, thinking back to what I have here, if I have thirds, I needed to have the same size section to be able to count how many sections I have, correct? We talked about that earlier. So am I really changing these sections if I'm counting how many sections I have? I'm not changing the size, and hence the last explanation, or possibly just one other explanation, of why 6 is not going to be the accurate answer. You're not adding the size, you're adding how many of each of those sizes you have. The size doesn't change when you're counting how many you have. The quantity changes because that's what you're counting. You're counting how much, not what size. Does that make sense? Okay, give me a thumbs up if